Hello and welcome once again for another Calculus 2 video. Today we'll be looking at an example problem. This one's going to be another Riemann sum type of problem. And it's about, we're heading towards the idea of the definite integral. So the question asks, evaluate the Riemann sum for f of x equal to x minus 1 when x is in the set -6 to 4, with -6 and 4 inclusive in that interval, with 5 subintervals, and taking the sample points to be right endpoints. Explain with the aid of a diagram what the Riemann sum represents. Well, I think actually in this case, answering the first part, or the second part, makes the most sense to do first, because it will also help us with our solution to the rest of this. So our function is x minus 1, which looks something like that. And we're going to go from, let's mark these off. 2, 3, 4. 1, 2, 3, 4, 5, 6. So we'll have these all nice and marked off. And so what we're really looking at is the area right under here, and the area over here summed together, basically. So basically in this case we want the area underneath the curve over here but above the curve over here. And this is actually going to be in some sense a negative area, because it's negative in the sense that it's underneath the curve. So this kind of helps explain the second part of the problem. The Riemann sum is representing these two areas where this is taken to be a negative because it's underneath, it's above the curve, and this area is taken to be positive because it's underneath the curve. Okay? So that's the second part. Which I'm not going to write out in full words, but you would be expected to, obviously, if you did this. Now, what we need to do is we need to take right endpoints, and since if we go from -6 to 4, we have 10 spaces, and we're dividing it into 5 subintervals. So what we're going to end up doing is taking right endpoints as these points. My boxes are not wide enough, actually. My bins should have gone here to here. There we go. That was that first endpoint. Then here to here. Then here to here, and similarly on this side, here to here, and here to here. Okay, so to figure out what those endpoints are, let's ask what are the right endpoints, the x values of the right endpoints. And that's going to be the set of the following: -4, -2, 0, 2, and 4. Because we're looking at right endpoints, which is over here. By the way, if it was left endpoints, this would have to be on the curve. The left side would have to be on the curve rather than the right side. And we also want to know the y values of those right endpoints. So obviously it's just this minus 1. So each of these values minus 1, so that's minus 5, minus 3, minus 1, 1, positive 3. And to get the Riemann sum, which is what we're really after, we need to sum over all of those intervals. So it's going to be from I equal 1 to 5, because we have 5 subintervals of the Ry terms of I. So basically I'm just going to index these. Maybe this was number Ry of number 1, and this is number 2, and so on. Number 3. Doesn't actually matter which way I order them, because summing them ends up being the same thing, times delta x. But here the delta x is, well, we have minus 4 to minus 2, minus 2 to 0, so on. So delta x is clearly equal to 2. So we can just write this out as being, and then I can actually take this delta x onto the outside because it multiplies every term. So I'm going to say 2 times, and then do the sum here, which is minus 5 plus minus 3 plus minus 1 plus 1 plus 3, which is equal to negative 10. That's my Riemann sum. And that's all that we had to do for this one. Our Riemann sum was this. And it turns out, actually, that this is a really good estimate of the true integral. That's all that I have for this video. I hope to see, or this is a pretty good estimate, I should say. I hope to see you again next time.